Hello everyone. Welcome back. We are going to learn about shoring for deep cutting. Whenever engineers excavate deep into the ground for basements, bridge foundations, or metro stations, the surrounding soil may collapse if it is not properly supported. To prevent this, temporary support systems called shoring are provided. In this lecture, we will understand what shoring is, where it is used, the different methods of shoring, and how each method works. Let's begin with the basic concept. First, let us understand the meaning of deep excavation. Generally, an excavation deeper than 15 feet or about 4.5 meters is called a deep excavation. When the excavation becomes deep, the soil on the sides loses its natural support and may collapse due to its own weight or groundwater pressure. To prevent this failure, engineers provide shoring, which is a temporary support system installed along the sides of the excavation. The main purpose of shoring is to protect workers, construction equipment, nearby buildings, and underground utilities until the permanent structure is completed. Now let's see where shoring is commonly used. Shoring is widely used in projects that require deep excavation. Some common examples include high-rise building basements, underground parking structures, metro rail stations, lift pits, utility trenches, and bridge foundations. For example, during the construction of an underground metro station, excavation may extend more than 20 meters below the ground surface. Without proper shoring, the surrounding soil could collapse and damage nearby roads or buildings. Therefore, shoring plays a vital role in ensuring safety and maintaining the stability of deep excavations. Several methods of shoring are available, and the selection depends on the soil condition, groundwater level, depth of excavation, and project cost. The common methods are contiguous piles, secant piles, sheet piling, diaphragm walls, and vertical soldier piles with horizontal lagging, also called the king post method. Each method has its own advantages and applications. Some methods are suitable for sandy soils, while others are preferred for deep excavations in congested urban areas. Let us now study each method one by one. The first method is contiguous pile shoring. In this system, reinforced concrete piles are constructed around the boundary of the excavation. These piles are placed close to each other, but do not touch one another. Depending on the soil condition, the gap between adjacent piles generally ranges from 50 to 500 millimeters. The piles resist the lateral earth pressure, while the exposed soil between them is protected using shotcrete, which is sprayed concrete. Contiguous piles are commonly used where groundwater is low and moderate soil support is sufficient. They are economical and suitable for many urban excavation projects. The next method is secant pile shoring. Unlike contiguous piles, secant piles overlap each other, forming a continuous wall with very little or no gap. Construction begins with primary piles, usually made of plain cement concrete. After they gain strength, secondary reinforced concrete piles are constructed between them, overlapping the primary piles by about 75 millimeters, or 3 inches. This overlapping arrangement provides greater strength and better water resistance than contiguous piles. Because of these advantages, secant pile walls are widely used for deep excavations, especially where groundwater control is also required. Now let's discuss one of the most commonly used shoring methods, called sheet piling. A sheet pile wall is constructed by driving prefabricated steel sheet piles into the ground. These sheet piles have specially designed interlocking edges, allowing one pile to connect firmly with the next and form a continuous wall. In sandy soils, sheet piles are generally driven using vibratory hammers, while in cohesive soils they are pressed into the ground using hydraulic equipment. The installation begins by positioning the first sheet pile. The second pile is then interlocked with the first, and the process continues until the required wall length is achieved. If greater depth is required, additional sheet piles can be welded to extend the wall. Let's understand the installation process in a step-by-step manner. The first step is selecting suitable pile driving equipment, such as driving hammers or jetting equipment. Next, each sheet pile is carefully lifted, positioned, and driven vertically into the ground while maintaining proper alignment. After all the piles are installed, they are inspected to ensure they have reached the required depth and remain perfectly interlocked. Sometimes a pile may not be driven correctly. In such cases, it is pulled out, corrected, and redriven. Proper installation is very important, because even a small gap between sheet piles can reduce the stability of the excavation and allow water to seep inside. Sheet pile walls act as a strong barrier against both soil and water pressure. They are commonly used for bridge foundations, cofferdams, riverbank protection, harbor structures, retaining walls, and underground excavations. One of the biggest advantages of sheet piling is its speed of construction. Since the steel sections are prefabricated, installation is much faster than constructing reinforced concrete walls. Another major advantage is reusability. After the project is completed, the sheet piles can often be removed and used again in another project, reducing construction costs. They also adapt easily to different shapes and can be installed in most soil conditions. The next method is the vertical soldier and horizontal lagging method, also known as the king post method. In this system, steel soldier piles are installed vertically along the excavation line at intervals of about 2 to 3 meters. These piles act as the main supporting members. As excavation proceeds in stages, horizontal timber planks or precast concrete panels, called lagging, are placed between the soldier piles. The lagging retains the soil, while the soldier piles resist the earth pressure. If the soldier piles are intended to be removed later, their bases are supported using gravel instead of concrete. This method is economical and widely used for medium-depth excavations in urban construction projects. This figure clearly shows how the king post method supports the sides of a deep excavation. Notice the vertical steel soldier piles carrying the earth pressure, while the horizontal lagging panels prevent the surrounding soil from falling into the excavation. As the excavation becomes deeper, additional bracing or ground anchors may be provided to improve stability. This diagram shows the structural assembly of the soldier pile and horizontal lagging method, including the use of wales, struts, and tiebacks for ground support. Let's quickly summarize. We learned that shoring is a temporary support system used to prevent soil collapse during deep excavations. We discussed its applications and studied 4 important methods: contiguous piles, secant piles, sheet piling, and the vertical soldier with horizontal lagging method. Selecting the appropriate shoring method depends on soil conditions, groundwater level, excavation depth, nearby structures, and project cost. Understanding these techniques helps civil engineers construct deep foundations safely while protecting workers, surrounding buildings, and underground utilities. Thank you for watching.